All right, welcome to the Explainer. Today, we're literally digging into a problem that's right under our feet. And we're going to explore a pretty amazing eco-friendly fix that comes from a place you would never, ever expect.
It's a question we almost never think about, do we? We just assume the ground is going to be solid. But what happens when it's not?
Well, it turns out, for huge parts of the world, the ground is actually weak. It's unstable, and it is a massive headache for engineers. And that's really where our story kicks off. So to really get a handle on this problem, we need to meet the main villain of our story. It's a specific type of soil from Malaysia, and it's called Batu Bahat soft clay. So what's this stuff made of? Well, look at this. It's almost entirely tiny, fine particles. We're talking 61% silt and 36% clay. That's 97% fine-grained stuff. Trying to build on that is kind of like trying to build a castle on wet flour instead of, solid rock. And yeah, that fine-grained mix, that's the whole problem right there. The particles are just so small, and they hold on to so much water that the soil becomes incredibly weak and just squishy. It compresses under any kind of weight, making it an absolute nightmare to build anything on. So in engineering terms, they talk about high compressibility, which just means the ground squashes down when you put something heavy on it. That causes buildings to sink or crack. And low shear strength basically means it can't hold up a heavy load. The bottom line is, this soil just is not up for the job. And we're not talking about a small issue here, not at all. As the source material points out, the cost to fix roads and buildings that are built on this kind of unstable ground is just staggering. We are talking billions of dollars every single year. So, how have we traditionally dealt with this? Well, the go-to solution has a pretty big problem of its own. For decades, the answer has always been the same: just mix in a bunch of cement. And look, it works. It definitely makes the soil stronger. But the downsides, they are massive. Cement is expensive, and making it is responsible for about 8% of the entire world's CO2 emissions. It's a really unsustainable fix for a problem that's everywhere. But what if there was a better way? This is where things get really cool. This brings us to a seriously innovative solution, a recipe that starts with, of all things, farm waste. So meet our first hero, Biomass Silica. It's a pozzolanic material, which is just a fancy way of saying it has properties kinda like cement. And the best part? It comes from agricultural waste. We're talking about things like rice husks. So instead of being garbage, they get turned into a super powerful building material. And every hero needs a sidekick, right? Well, our second hero is sodium silicate. The easiest way to think about this stuff is like it's the super glue in the recipe. Its entire job is to bind all those loosey-goosey soil particles together, creating a strong, solid structure. So the researchers had this simple but brilliant question. What actually happens when you mix this silica from waste and this chemical glue right into that weak, problematic clay? So they did it. They put this recipe to the guest. And the results? Honestly, they were nothing short of dramatic. Okay, check this out. This chart tells the whole story. On the far left, you see the pathetic strength of the untreated clay. But then look what happens when the new recipe starts to cure. After 28 days, the strength has absolutely shot up. And by 90 days, it hits maximum strength. That is a massive, massive improvement. Now, to really understand why this is such a big deal, you need to know about a test that engineers use called the California Bearing Ratio, or CBR. It's how they measure if soil is strong enough for a road. For that bottom layer of a road, the subgrade, you need to hit a minimum CBR value of 12%. That's the magic number. So, did they beat 12%? Oh yeah, they didn't just beat it, they absolutely smashed it. The treated soil hit a CBR value of 85%. That is over 7 times stronger than the minimum requirement, and that was even after being soaked in water. Incredible. So the question is, how? How does this happen? To really get it, we've got to zoom in, like way, way in, to see the microscopic makeover that's going on. So before you add the treatment, under an electron microscope, the soil is just a loose jumble of individual particles. You can see all those empty spaces, all those pores between them. That's why it's so weak. But after the treatment, it's a whole new world. Look at that. Those loose particles have been locked together into this dense, interconnected matrix. All the gaps are filled in. You've got a solid, unified structure now. So here's the chemical magic behind it, broken down into 3 simple steps. First, the additives basically make the little clay particles attract each other and clump up. Then, the pozzolanic reaction kicks in, and that biomass silica creates this cement-like gel that fills in all the empty spaces. And finally, the whole thing just solidifies into a brand new, super strong, and durable structure. Okay, let's zoom back out. All this science is fascinating, but what does it all mean? What's the big picture here? Why does this really matter? Well, this is a genuine, sustainable breakthrough. It's a game changer. You're taking something we used to just throw away, agricultural waste, and turning it into a hugely valuable resource. It gives us a real alternative to that carbon-heavy cement, letting us build stronger, longer-lasting roads and buildings, all while doing it in a much greener way. And that leaves us with one last really fascinating thought. This technology took rice husks and turned them into a construction powerhouse. It just makes you wonder, what other waste materials are out there, just sitting around, waiting for us to figure out how to transform them into the building blocks of tomorrow?